Hi everyone, my name is J.K. Fleet, and this video I'm going to be showing off the spider robot I made. So there's a demo video, like with my other stuff, where I kind of just gave a overview of what the robot does in kind of a more condensed video. But this one's going to be about explaining my process of how I made it. So I have the both the spider and the controller on my desk here. I might show off or just like hold them up and demonstrate a little bit as I go through. But I do have them, so that's kind of nice. So my initial goals for the project was to create a spider robot that had 4 legs. I wanted 3 servos to be on each leg. The input would be controlled through a Bluetooth or wireless module, and the controller through an Arduino Nano. The breadboard Nano would be placed at the center base of the robot, and it'll need multiple power supplies for the servo and the Arduino Nano on the spider robot. And I wanted to make the robot respond to sound or lights. I ended up just using the controller, but that could be something that could still be applied in the future. Okay, so let's go to the first part. So section 1 was all about designing the legs. I needed to design a mount or some type of like center base that could go along, that could connect each of the legs. I needed to design different joints to attach these separate servos. I needed to make the holes non-threaded but have enough clearance for the type of screws I had. That was something I kind of figured out through the last project. And I needed to design the other joints. So here's a picture of the first one. It's huge, or a lot bigger than this one. Throughout most of the design steps of the project, I realized that using 3 servos and having it this big was just not working with this, how much the servos could keep up. So I ended it up and one of the third version of the design that I ended up keeping at the end is ended up cutting it down to 2 servos. So then right at this second joint here, since the servo was right here and right here, it would put a lot of stress on the legs, and it just didn't have enough to keep it held up, even when like there wasn't anything on the base of the robot. But yeah, so the joints, getting the servos connected to the joints worked, so I kept that. I just ended up crunching down the legs, which wasn't too bad. It was just kind of tedious with the 3D printer, but like I said, that just took time and eventually got it done. So to reflect on this, the servo mount pieces needed a 0.2mm clearance around the hole. Servo screws needed just a regular hole. That stuff was pretty easy. Mounting the servos between the parts wasn't too bad. I think I found a lot better way to do it than in my last project. The black screws I had needed a clearance, like I said, since they are a little larger. I ended up ditching the black screws and made the connector pieces a part of the joints, made it easier to use the supports in 3D printing software. There were like these little, let's go back here. So in this, I had on each of these parts, I had these little screw holes for these tiny little circle pieces, but I ended up just making the circles part of the joints, so then I could just cut out that piece in general. Because for every leg, like here, this top part here is connected to the actual servo, like the horn, but then this bottom part here, you can kind of see the circle, and so I cut out a hole in this joint and put it in there. And it doesn't help move it, but it does kind of keep it locked in place for that joint, so then it doesn't like slide left or right. So that worked out really well. Let's see, section 2, designing the base and controller. I needed to figure out how I wanted to control the spider. I ended up doing this with some wireless modules that connected to the Arduino and a breadboard filled with buttons, which is this guy. So this thing isn't really complicated. I really didn't need to like make a box for it, but I just figured, I put all the time into it and it wasn't too bad. But you could just use a breadboard and put the wireless thing on it. But what I ended up doing was, you can kind of see the separate kind of actions you can do, and then it has a little spider logo and my name on it. This is the battery box. You can switch it on and off. It's currently on right now. I'm gonna turn it off to save some power. But yeah, it's pretty simple. The hardest part for this was probably figuring out the code for the wireless receivers, because you have to set one side of it to basically be sending data and another side to be receiving. So the spider receives the data. And so based on whatever button you put, it'll send a number 1 through 8, basically saying what action you're doing. And then in the spider code, it basically queues up, oh, you hit the first button. So then it's going to do the first action, which is move forward. Or, oh, you hit the third one. So now you're going to turn right until you hit another button to make it change and do something else. And it'll keep moving in that state until you tell it to stop. And button 4 on here, the last green one, it basically tells the robot to just stand up and stay still. So you can kind of turn it, stop it, make it go forward. It's a little easier to control when you have a stop button. But yeah, I wanted to design the base to keep the Arduino breadboard, 2 power supplies, wireless module, and LED eyes. Yeah, so you'll probably see that in the next pictures. I did initially plan on the base having a little face and some eye holes that I could put LEDs through to light up. But I got so worried about reducing the footprint and the size of the robot that I ended up cutting off part of that, and I ended up just condensing everything so tight just so it could keep moving. I need to figure out if an Arduino servo shield would be better. At first I planned on the actual spider using an Arduino Mega, which would have been about the size of this whole top green PCB board, but the Nano's a lot smaller and ended up getting the job done. I ended up just getting a servo driver, which is this kind of other module here, where basically what happens, it's right up here. It has 3 pins, so you can plug the servos in directly and you don't need to use a breadboard or extra wires to hook it all up, and it makes it so there's a lot less wires and it's a lot cleaner to just do everything. So I was really happy that I ended up using the servo driver because it ended up being smaller and more efficient. I need to add a base attachment for each spider leg. Honestly, I don't know what that means. I think that just means add like a little place on the base for the legs to mount on for the first servo. I thought I already did that at this point, maybe not. Designed the controller for the buttons and receivers, so I just imported the CAD models for like the breadboard, the buttons, and the Arduino, and I just kind of built this kind of oval ellipsy thing around it, and I cut a hole for the battery. It wasn't too complicated. I added some screw holes on the top here, these black ones, but yeah, it wasn't too bad. If anything, the point that took me the longest on that was probably just designing this little cover piece, because I added a lot of text and numbers and just like a fun design, because you know I had room for it and I really liked it. Test spider leg joint sizes so when the servos are bent it's at good heights. Yep. So here's my pictures. Here was the first iteration of the controller I did. I don't think I have any pictures of it. Okay, yeah, I do. So that's when I actually printed it. So it ended up being, I ended up moving the buttons around on the breadboard so that they would fit across the middle of the breadboard, because that was the easiest way for them to basically all fit. And so instead of doing 4 rows, I ended up just making 1 row, and I just had them a little closer together, and I scaled down the size of the little symbols, but it ended up working out. I was a little worried about it, but you know, it's not a huge deal. They're just on a breadboard and it fits pretty well. To reflect, ended up buying the wireless receivers and buttons to make the controller. I got the Arduino servo shield, so I not need a breadboard on the spider. Got more battery packs. Spider controller is not very complicated, and the buttons just stick out through the cover. Like I said, gets the job done. Designing the base was not bad once I had the spider legs done. I added a happy face and LEDs to spider. Like I said, that didn't stick. You can kind of see it right here. Those little white parts are the LEDs, or where they're supposed to go, and it actually fit really well. I just like I said, the front and back of the spider, like I said, there's no cover. It just has the battery sticking out because I wanted it to be as light and small as possible. But yeah, so this next part is all kind of about the code, so I kind of go into some of the code and maybe talk about it. I'll wait to get into the spider code at the end because that's probably the biggest. But I wanted to start writing test code for the separate modules. I wanted to do that for the wireless receivers. I wanted to write a piece of code to basically set all the servo joints at 90 degrees so that I could rotate them to 0 or 180 degrees from its initial starting point so that they were in good positions, because they can't go all the way around. Try to get input output from the buttons on the controller. That ended up working out well. Write code for setting up the LEDs and robot eyes. Ended up not using that, but the code was still there. It wasn't very long. Worked on the code to queue up buttons inputs on Spider. So here's some pictures of me just having breadboards, messing with stuff. This picture on the right here is the breadboard setup for the buttons. Each button has one part of it going to the ground, one part going to the 5-volt line on this breadboard, and another sent. I'm pretty sure the positive side and the digital go to the same side of the button, and then the other side goes to ground. Because then when you push the button down, it's like a bridge, and then it basically connects both sides, so then it gets the power and ground, and then it sends the digital as it's on. Because it's a binary 1 or off. It's an on or off, so it's a 1 or a 0. And so that's what I use to send the signal to the Spider. So if you look on the right here of the screen, kind of with the Arduino here, here's some of my code. So what you have to do is get these libraries. The NRF24L01 is the name of the wireless receiver I use. So I found a library online that could make using this code a lot easier in this module. So the main idea of this is you have to have a 5-letter or string address. And so as long as the sender and the receiver is on the same address, you can basically send signals to each other. So it's kind of nice because I could use this controller for other robots I make if I gave the receiver, that robot, the same address, and I could use the buttons to control it, which I like. The CE and CSN, you have to define 2 pins that you plug into from the wireless receiver. The other ones are a 3-volt and a ground, and then the other 3 have to go into 3 specific pins that vary based on what Arduino you're using, because it's different on a Arduino Nano than on Arduino Mega. So here I have the digital buttons that they plugged into on the breadboard, or on the Arduino Nano for the controller. You can use either analog or digital, and since I was using some of the last digital ones for the wireless receiver, I used some analog ones. And then I just have some arrays to keep track of the information. So in the setup here, I have it so there's a for loop that basically sets up the buttons so that they can be recognized to get input. And so I have this thing called isButtonActive, which basically goes from false and true, and it makes it so when you press down on the button, it won't repeatedly send that input to the Spider. And so basically, once you send it once, and when you're holding it down, it won't send another button unless you release it and press it again. So then you won't just keep sending the same input over and over and flooding the Spider, which is really nice. But yeah, so one of the buttons just fell out. Yeah, one thing with the controller is sometimes the buttons are a little they're a little like loose, and I need to, if anything, I need to unscrew it and kind of press them in again, but they get the job done. It's not a huge deal. So these few lines of code that I'm highlighting here in yellow. So with the library that you get for the wireless receivers, basically you name it RF24, that's the object, and so then you say, I named mine radio. And so I did radio.begin, and that basically starts it with the library. And I said open writing pipe, and then with the address. So that basically sets it up so you can start sending information over that address on that signal. And then this is just something to help kind of hone in on that. And then radio.stop listening basically says, hey, I'm not trying to receive information, I'm trying to send information. And then I open the console, basically so I could check my data as it's being sent. So this loop right here basically reads the data. It just reads what the state of each button is. It's either a 1 or a 0 based on if you're pressing it. And then this basically processes it with, like I said, is if it is active. So basically it tells you if you're holding it down, if it's released, and saying. And if you just press it, it'll basically, what it does is it sends that button, which button you pressed, over the wireless receiver. So then at this point in the code right here is where the Spider robot would get it. And yeah, so that's about it. It's not super long. It's really easy to use. I'm really glad that I bought, I think I got 10 of them in an Amazon order. And so I have more of them. I'm definitely going to use them for things in the future. They're really nice, but I like them. So section 3, reflection. The wireless receivers are really nice modules to work with, like I said. Right now the LEDs will always be on. I ended up using those, so it doesn't really matter. The code for the controller is pretty simple, mostly relying on the wireless library and the digital pins for the buttons. If you need more pin room, I will make some of the buttons use analog pins. Ended up doing that because that's what I needed, but it worked out because the buttons are just digital. They're really easy to use. Really like the code for inputting and queuing up the buttons between the controller and Spider. It's really short and sweet, really efficient. With this stuff, it's definitely easier if you have less data being sent. So if I can just send one number over when I need to, it's better than just spamming the numbers across. But yeah, so section 4. This was a lot of like printing, soldering, kind of putting everything together for the first time. I want to print off the leg pieces, the Spider base, the controller parts, soldered the LEDs, soldered the Arduino Nano to some pin headers, get the legs hooked up to the servos, get the buttons on the breadboard, figure out the pin hookup. So this was where I spent a lot of time on this part, because this was seeing if what I planned out all worked together, seeing what worked, seeing what didn't. A lot of redesigns in CAD, a lot of reprinting. But it was really fun. I really enjoyed it. While I was kind of struggling with the Spider Robot, I ended up focusing just on getting the controller finished. Like I said, here's the controller without the piece on, so that's what's going on inside of here. Not super complicated. Like I said, here's the breadboard I showed. The Arduino Nano's right here. I left a little hole right here so I can basically plug into the Nano if I ever want to change the code. You can see it right in there. But I took it out because it was just kind of hanging out. And then the battery. So not too bad. But like I said, here's the initial robot. It's huge compared to this little guy. I don't know if it's hard to tell. I honestly kind of want to put the pieces together and just like compare the footprint of them because it's pretty interesting. But my next few phases are kind of just redesigning it. So we'll see that in a minute. So soldering went a lot faster than expected for this project. I didn't do a ton of soldering until the end, but I do feel a lot more confident with it. After the LED cube, it's been a lot less tedious, and I feel like I've been getting a lot better at it and more confident with it. Printing the leg parts was easy, except the second joint had trouble printing due to the small width between the edge and the piece. So there was there was a day where I just kept reprinting the same part, trying to hone in on what the problem was on the printer. And that was a whole learning lesson in itself with 3D printing. But like I said, this part took a long time because I had to print a lot of pieces over and over again. Ended up redesigning the controller since the buttons were having trouble, which the redesign is to what you see now. We'll have to do some heavy redesign to the base and the legs eventually since it's way too heavy. Section 5, Spider redesign, number 1. Redesign the base so it's way smaller, make joint 2 on the leg shorter, make joint 3 on the leg thinner and shorter, make servos connect at the corners on base, make as light as possible, reprint new parts, and test. So this is probably where the biggest change was made. Like I said, this part of the base, this kind of block in the middle, I roughly measured out the dimensions of the 2 battery pieces combined, and I just basically just squished everything down, cut pieces back, put the servo base mounts closer together, and I still made it even smaller. But then I basically went this redesign where I had these little brace mounts up here, these little plastic mounts that basically just screwed right into the PCB board. And so I don't know if you can see that here. Let's do it this way. This way you can see it. So right there, you can kind of see that little plastic part sticking up. It's screwed on there, and then that is screwed to the soldering, or the prototype board. And so basically right under it is all the soldered wires, but it made it really easy because I could mount this stuff right on top of the batteries, and it made it really nice to compact and reduce the size of it. And I really wish the first design worked, but it was just too heavy. Honestly, it might have worked with how I have 2 legs now, because once I went to 2 legs, the stress on it went a lot better, but that's in the next redesign. So I reduced the base footprint from about 76 grams to 30, so I basically made it a third of what it was before. This was huge just for the base alone. I kind of figured I was on a good track at that point. I got lithium AA batteries to reduce the size from servo power supply 2. They're lighter, which is really nice. That's really helpful because it was before it was 4 alkaline AA batteries, and those are pretty heavy. Hoping that since the legs are more condensed, the load is easier. The load was easier, but like I said, having 3 legs was still rough. Printing off the parts went faster since they were all smaller, which that was nice. As I did go farther in the project, it was easier to print stuff out, but that first run took a while. The base is about 1/4 of its original size. The legs are much closer together now. Redesigned everything except for the first connecting joint on the leg. Might still make shorter, but not by much. So yeah, so like I said, section 6, this is the kind of last redesign. So I redesigned the legs so there's only 2 servos. And so this was done by basically what I did, as you can kind of see here, where's my picture? So this joint right here, I basically just cut it out, and then I made this leg joint wider. So then, you know what, I'm just going to get in them. I'm going to pull up my CAD model just so I can show you guys, because that's a little easier. But yeah, so this part, it has it so there's that little like circle hole mount on the other side of it, and it just kind of clicks in, and then you mount it and screw it in with the little servo part right here. Oh yeah, hold on here. We'll get this guy up in a second, but focus on this for a minute. So yeah, so it's way smaller now. Basically, I think the issue with it was so much how long it was, and just these guys just struggled so much to support it. But I'll show you. So I have the different iterations saved in the folders here. I should have pulled this up before, but that's okay. But then, yeah, so this guy's pretty small. I really like this design. I kind of like how it's kind of shorter and more like hunkered down. It still kind of feels like a spider. It was a little hard to code the legs since I didn't have that second joint to move this part of the leg up as it swung over. But ended up working out really well. The guy kind of zips around, but it works out. And so using 2 servos per leg gives me the option for using 6 legs. Probably not for this project, but maybe for more in the future. I can make the base a little longer and give it 6. That might be kind of fun. For now, I'll stick to 4 since I can reuse my current base that I printed. Like I said, it was really nice because I only had to reprint the pieces. I only had to reprint joint 1 and this new joint 2 leg type of thing, and that probably only took, the legs were about 45 minutes, or no, they were about half an hour, and then the joints were about an hour. So compared to how much I was having to print before, it wasn't too bad. It wasn't too bad. But okay, yeah. So I ended up redesigning it, or adding it, this little like part to the legs. I ended up printing those off, but I didn't use them because I kind of liked how much how wide that these legs kind of covered. At first I was worried about it, like see how they're long like that, because really just like this part right here I didn't end up doing. But I still designed it, printed it out if I wanted it, but it made it a little taller, and I kind of like how low it is. But so as you can see here, right in here, there's this little circle part. So what happens is, can I select these? No, let's go to this leg. I think I can do it. So yeah, okay, let's just get this leg here. So as you can see here, the CAD design, so you have the servos basically mount onto the pieces with the screws that come with them, and then you have this is like the servo horns that come with them, and then I basically just extruded a hole out of them. So then, let's see here, servo arms. I don't know why they're still showing up, but that's all right. But yeah, so this part is like an actual little plastic piece that come with the servos, and so there's a hole for that in this. It's a little wider than it, just for user error. But then, like I said, there's this hole here that is connected to this piece, so it kind of helps keep this servo side connected. But yeah, so that's about that. Put these guys back here. This CAD software is so nice. It's a lot of tweaking and a lot of printing, but once you get it like honed in, it works really well. But yeah, I'm really happy with how this design turned out because it made it so I could code the movement really well. So here's probably the main part of the last part of the project. So this is definitely this is the code for the spider. It's about 300 lines long, and there's a few different things kind of happening in it. So I'll just talk about my goals first, and I'll maybe walk into the code. So I wanted to add functions for moving forward, backward, left, and right. And then I wanted to add functions to do other fun actions. And so basically what this was is like things like a push-up, just like dancing, standing still, you know, just stuff like that. Things that I can very easily change. They're a lot less complicated than the movement. I added a switch case so that I could queue up actions from the controller. And I wanted to solder the Arduino Nano and the wireless receiver to the prototype board, and then mount all the parts together, which I did yesterday. So here's the underside of the board when it's soldered. It's kind of a mess. I ended up making the braces a little taller so that the wires wouldn't directly be smushed against the batteries. Here's the top side of it, pretty clean. Here's the part without the mounts on it with the batteries attached, and then here's it with all of it on my bed. So let's go into this code here. So I'm gonna bring this over here, and I'm gonna swap these out just because I know my face kind of covers part of it. So like I said, I had the libraries for the wireless receiver, and then I have another library for the servo driver. And then this stuff is basically data that I use to change the angles with the servo driver. And so you basically make this object with the servo driver library that you use, and then you can use it to write and change the angles of the servos. And so here is basically a 2D array for the number. It's the length of the number of legs and then the servos per leg. And so this basically defines which pin on the servo driver each servo is connected to. And then I didn't end up using that. I can honestly delete this. Didn't end up using that offset. But so then I have a few different arrays. So these are basically they're 1D arrays, and so basically it sets the angle for each of the joints. So joint 1 parallel is basically when the spider, the legs are parallel to each other like this, and so the angles, like for the first joint, servo 1, it'd be 135, the next one's 41, and then so I had these set for when they're parallel, when they're moving, the servos are moving forward, and when they're backward for these. And so the joint 1 is basically these, where you move them kind of like this. But yeah, so then joint 2 are the actual legs, and so you can have them so they're right, so they're standing up to where they are parallel, or so when they're like kind of up like this, or when they are inside like this. And so it was really nice because I then made functions down here to basically set them at like set J190, set J290, set J2 right. And so then I used this other function I made called set angle, where I basically, it was up here where I actually call what servo it is and what the angle is. And that's where I use the servo driver. But I made all these functions because basically these were like little movement instructions to where I didn't have to actually write the angles, and I could fine tune those at the top of the code, and I could basically just do all of the movement by basically saying which leg I wanted to use and which joint I wanted to use. And it made it so when I was worried about basically mapping out how it was going to move, because it's pretty complicated. So these are all the actions that it does in between movement. So it kind of like picks up 2 legs, swings them to the side, the other 2 slide back, and then those ones set down, and then it like mirrors and reverses itself. And it was pretty hard to plan out, so writing those functions made it a lot easier. And so it's pretty much like that for moving backward, and it's like that where you kind of just use these commands. It's kind of hard to explain when you're just looking at it. It'd make more sense if you just probably watched the demo of it moving. But in between, I have to delay it at some point, because if you don't delay it, all the servos will try and move at once. And so the movement delay is pretty low. It's 100 milliseconds. So it's pretty fast, and the faster it goes, the lower the delay, the farther it can move and the faster it is. This was a pretty good speed. I I was pretty happy with it. For the actions that I did, I made it slower, so it wasn't like waving super fast. It was just kind of like a hello. Um, but yeah, I guess I'll show off the switch case. So a switch case is basically just like a if-else statement, but a little easier to use if you have a lot of conditions. So what I do is, this is the other side of the wireless receiver. If radio.available, it basically checks if the other wireless receiver is sending a signal over, and if it is, then you read what that value is, and then you put it into what I have as current button. And so basically, say if nothing's on it, and then I hit the second button, which is backwards, it'll read that as a 2. And then, so the switch case, it'll be switch current button. So then it wonders, okay, well, what number is current button? At that point, it would be a 2, so it would call the function move backward. And until I hit another button to change the movement, it'll keep moving backwards. So you only have to hit it once, which is really nice. But that's kind of the main loop, is this scanning the radio, seeing if you can pick up a different button, and then doing the switch case to change the action. So it's not too complicated. Really just coding the movement of the spider was probably the hardest part. Everything else was pretty straightforward. I had some troubles wiring up the wireless receivers, but like once I got that working, it was good. But yeah, it was really fun. I really, really liked it. But yeah, so that's the code. The code will be posted on my GitHub. I'm going to update that and add a link to that on my website. So yeah, if you're interested in that, you can check it out more. But I ended up ditching the button queue method. I was really happy that this design could support all the way to the parts after I actually put them on. Coding the other movement functions, I guess I'll switch this back again, that's how it normally is. Coding the other movement functions after figuring out one wasn't bad, since I could mirror the forward and backward and the left and right. But yeah, so final reflection. This project taught me a lot about weight management with the robot. I think there was a point where I was really ambitious and I was like, oh, let's like do this, and this. But I was like, I needed to kind of step back and think, like, what is the footprint of this thing going to be? Is it actually going to be able to support itself? No. It took me 3 tries to figure that out, but, that's part of it. I didn't consider size initially in my project since I was worried about the design and like how everything would connect. But once I figured out how they would all connect, I could start crunching it down and making it more efficient. Once I minimized the size of the spider, like I said, it came much easier. It was really fun to use different servos to write the functions and make the spider move. I really like the feedback between the controller and the spider. It just feels really snappy and good to control, and I'm really happy with it. I also enjoyed soldering together some of the Arduino parts on the prototype board. I really like kind of designing these, like soldering and doing it. I kind of want to get into like designing circuits, like actual ones, because then it'd be nice because I could just solder the pieces in place, and since they're already like connected like that, it could be like that. And I know there's websites where you can do that, so I might look into that for something in the future if I have something that needs to be like kind of small and compact like this. When I work with servos in the future, I'm definitely going to start with the smaller parts and try and like make as much make as much is small. I don't know, like make as many holes and room and just make it sturdy yet light. And then maybe work my way up to more complicated stuff, because I still have a lot of good designs for the spider robot and it could be used for a lot of stuff in the future, like maybe have different sensors to make it move, because I could still use the movement code that I have, but have like a sound sensor on it to make it try and turn and hone in on where someone's at, which would be really cool. But yeah, I think that's about it. If you have any questions or interests, you can leave a comment. You can go check out my code or read more about it on my website, because I plan on getting that updated after posting this video. But thank you so much for listening. I think I'm about at 30 minutes here. But yeah, this is kind of my last project of the summer. I'm moving back in a week. I don't really know how much I'll be working on stuff in the future. I want to be doing something, at least, pumping out ideas, but it probably won't be as often, but I hope either way to keep it updated on the site. I think I'm just going to kind of keep the site in like a year 1 state right now, and then once, or I might even at this point kind of chalk this up as like year 1, and then this next year will start like year 2, so I might have different sections for that on my website, but I'll still have everything up But yeah, so thank you so much for watching. And if you want to do more, you can check out my website. It'll be all on there. Thank you.